Hello everybody, I'm Benoit Montreuil. I'm very honored and pleased to present to you this keynote today. And I want to thank the organizers for having invited me to do so. Today I'm going to talk about obviously the physical internet, but give it a different spin from several talks that I've done in the past. Because I'm going to essentially focus on how can we use the physical internet concept and ideas and principles to shape what I call a global hyperconnected logistics infrastructure. So this will hopefully become clear as I will proceed through the presentation. Since we're far away, I thought I'd at least show you my face with a background that I loved, which is overlooking Shenzhen on an afternoon. So I would have loved to be with you all in Shenzhen today, but due to COVID, that proves impossible. So let's recap what the physical internet is all about. My latest version of the definition, which I prefer right now, is calling it an hyperconnected global logistics system that enables seamless open asset sharing and flow consolidation through standardized encapsulation, modularization, protocols, and interfaces, so as to improve the capability, efficiency, and sustainability of serving humanity's demand for physical objects. The definition starts with hyperconnected logistics system. I mean, when I'm saying that it's hyperconnected, it's because essentially its components and actors are to be intensely interconnected on multiple layers, ultimately anytime, anywhere. Those interconnectivity layers are digital, physical, operational, business, legal, and personal. So now I'm referring to logistic infrastructure. So we all know that we have an energy infrastructure, transportation infrastructure, and information and communication infrastructure. But we rarely think of logistics as an infrastructure. I make the claim that with the new way of thinking about logistics, as exemplified through the physical internet, in fact, we are gaining much more by thinking about logistic as being a joint, common, shared infrastructure. And that's what I'm going to be focusing the full presentation. Now, this infrastructure is going to be interlaced very tightly with the supply chain infrastructure. Today, I'm not going to focus on this one, which is leveraging the logistic infrastructure to perform, but rather focus here on the logistic infrastructure itself. Now, part of this infrastructure, for those who have been dealing with physical internet for a long time, they're pretty clear and obvious. But for those who are jumping into physical internet, this may not be as simplified. So I will be going from the basics, going up afterward. So one of the key basics is the fact that we're talking about ubiquitous modular containerization. So you have the big containerization at sea level, okay, so the 20-foot, 40-foot, 6 meters, 12 meters type of containers. But we were thinking about a modular version of this and much more aligned to physical internet principles. So the containers we're talking about are going to be replacing the packaging, the boxes, the cardboards, the classical pallet loads, the cages, etc. Okay, so in fact, what we want them to do is to be enablers of easy, seamless logistics. So they have to be easy to handle, to store, to transport. They have to be smart and connected, starting simple and growing afterward, being eco-friendly, so that they're as minimally damageable for the environment. Now, on the containers, we actually recognize three types of containers. We have the transport containers, roughly talking pods, then the handling containers that are meant to fit within transport containers. We're going to be talking about totes, boxes, to make it short, and then the packaging containers. So think of them as a mixture of Lego blocks and Russian dolls, essentially. So they offer overall a private nest in an open space. Okay, they are to be used throughout the physical internet, not devoted to a single building or single company or single club of company, etc. They can be owned by a producer, a pooler, a logistics service provider, or users. They can be transacted on the spot as pertinent. There's no need to return them to source since there are many that are going to be used, and we're going to reuse them numerous times. And overall, with the characteristics we've mentioned, they are to drastically ease handling activities. Now, focus on the containerization, but at the same time, we have to focus on the handling equipments, okay, that are going to be used to handle such containers, much easier than the normal cardboard boxes or typical pallets. And I'm showing an example here of mobile racks, okay, a bit like Kiva is using, or Gray Orange, and those companies with mobile robots in fulfillment centers that essentially are designed. Those that I'm showing, they're designed to fit essentially like a handling container, large one box, like a 1.2 meter square and maybe a 1.2 or 2.4 meter high, and essentially fitting into transport containers. And we can put tote size containers into it. So those are examples to make life as easy as possible. Now, another facet of the logistic infrastructure we're talking about is to have rely on open access, shared, fast response, agile facilities. And in fact, we can simplify by telling that, in fact, there are kind of four types of facilities that are at the core of this. First are customer interfaces. So that's where we showcase products, that we allow people to try products, to purchase them, to picking them up, okay, returning them, etc. So they range from retail stores, okay, but also smart lockers, click and collect drives, and the likes. Then we have the logistics hubs. Now, from now on, normally the consumer doesn't touch them. Those are for professionals in the logistics industry. So logistics hub, essentially, they are mostly with objects that have been ordered by somebody and are on their way to destination. So we need to consolidate them at hubs, cross-docking them, sorting, swapping, transshipping. Those are the keywords we're dealing with. And it ranges from all kinds of hubs that could be road-based, but also airport, rail yards, ports, etc. And clearly there's to be multimodal hubs in there. Then I go to what I term here deployment centers. Okay, so this is where we are going to put objects not yet requested by customers or users and pre-positioned for convenient demand fulfillment. They range from warehouses, slow-moving, deep storage things, depot, mixing centers, consolidating multiple factories, distributions, feeding retail centers and fulfillment centers, responding to demand from consumers and the likes, etc. And then we have production fabs, and essentially they're the one making, assembling, disassembling, recycling, processing products. Okay, they range from big factories to tiny personalization centers, 3D printing centers, and so on and so forth. So the logistic infrastructure that I'm going to talk is going to be comprised of such facilities and being owned by numerous owners, but what we want them is to be as much available as possible to the overall industry according to protocols. Let's look at the logistics hubs to just get the gist of the kind of capabilities we're talking about. So I've started by the activities that are going to be outside of a building. They just need a yard, okay, that's protected and well designed. And For example, I can get 2 trucks at that place and essentially swap the drivers, so that driver A comes back home and driver B come back home, and with different loads in there due to different trucks. I can also swap the carrier. Okay, so this means that if I've got like a truck and a semi-trailer, I will unhook the semi-trailer at the hub and pick up another one, go back home, and another driver coming back later on will unhook again his or her semi-trailer from the truck, and will hook another one and go in the direction that he or she prefers afterward, in line with what the semi-trailer needs. So there are all kind of things in there. So I can do also tractor swapping, so the same kind of logic, especially when we're dealing with the forthcoming technologies with electric cars, electric trucks, that would need times to recharge. So in order to get speedy to destination, if it's not that far, then we can have the driver and the semi-trailer stay together, but just change the tractor pulling it, the one that is fully charged. Then I can also do a transport container transshipment that is used in many places. Okay, here in Atlanta, near Atlanta and Savannah, Georgia Ports Authority is using these kind of deals in inland ports across Georgia, which is basically transferring containers from a truck to another, from a train to a truck, and vice versa in there. So all this is out. There are also activities that will be done inside, okay, again synchronous or asynchronous, and they're mostly consolidation. Okay, so first I can receive parcel, freight, etc., in various sizes, shapes, etc. And one of the jobs is to say, okay, we're going to have to put this in containers, so that in the remaining of the network, we will not deal with specific parcels or goods, but rather encapsulated ones into containers. So that's my left side in there. And at some point, it doesn't want to stay in that container anymore because it has reached the last stop toward delivery or final and I need to switch it to another one. I can also have containers, okay, that are put like in the mobile racks that I showed earlier. They're put out of the truck in one piece. All the goods that are in each of those tote containers still want to move together later on to the next stage, but they don't want to go to the various tote containers don't want to go to the same destination. Here I'm exemplifying this with the next destination being colored, and what I want at the end is I'm receiving multicolored racks, and what I want at the end is to have single colored racks that are going to go in the appropriate truck for that destination and go there. So there's no opening of the containers, it's just reshuffling them through the hub. The other one is essentially that now I will just do containers. Those would be like bigger containers, like the boxes I've mentioned earlier, or the racks themselves, that just needs to be put from one trailer to another. So easy in that manner. So from the left to the right in that figure, the cost is obviously going down when I'm going toward the right, because it's much easier to do. So those are the kinds of activities. I want perspective with the changes that are happening in the world. We all know that the demand for e-commerce, online goods has increased as much in the last few months that it has in the last 10, 15 years before that. So there's a huge steep increase going on, and it's not going to get out. So we're in a world that's going to be more and more omnichannel, e-commerce led, but with a lot of physical aspects to it. So here I'm showing from receiving things at home or to me directly, or me picking it at a locker, at a drive, or at a store, at a point of sale, and showing the various entities that are engaged in making this happen. And essentially we see fulfillment centers, distribution centers. I'm going more toward production. I see mixing centers, factories in various suppliers, even with the parts, okay, the materials and the parts suppliers. And I see various logistics centers and, okay, logistics hubs, which are the little cross here, that circle and cross. So think of this, that if you're a company and want to really serve your customer all around, okay, that's the kind of network you would have to put together. So if every company tries to do this, the world is going to go into bankruptcy, okay? So it doesn't make sense. So that's why we say that we need to work in terms of hyper-connected logistics to do so that we can have this open asset sharing, the various types of goods here, of facilities here, and as well as flow consolidation to make sure that we drive this and avoid having plenty of empty vehicles driving along to meet those demands. So that's the spirit of focusing on the facilities side here. If I pursue my journey with the logistic infrastructure, it's also enabling multimodal and omni-source transportation. Well, multimodal exists, okay, there's no point there, okay? So what I'm showing on the left side is the various types of modes, okay, that are kind of dominant in there. So you've got air, you've got maritime, rail and road associated, and it goes from very traditional vehicles to completely autonomous vehicle. So we have to understand that as we evolve our logistic infrastructure, it has to be able to leverage the availability and capabilities of the various ones, and they're going to be useful at different spectrums. So I've colored them depending if they're like first last mile, like mid-mile, long haul type of things. But depending where you are and where we're going to be in time, some will be more or less dominant. So we need to be smartly being able to go and do this multimodality and do it as best as possible in a synchro model perspective, making sure that I'm not waiting too long at each place, that everything is well planned for fast, limited dwell time at hubs and easy connection to the other modes. Omni-source transportation is an original idea that we had at Georgia Tech, okay, that fits nicely into this and was developed through several research projects that we have. So the idea is to smartly and dynamically leverage all the sources that we have on transportation. Okay, so it can be we can have our dedicated fleet, okay, our own or through some partners that we have. We can also leverage contracts, okay, smart contracts with service providers that can help us. Okay, we've signed maybe for a few months, for a few years. It depends on this more or less constraint. What is smart to sign as contract? And there's also the on-demand spot market, okay, with crowdsourcing and all the variants. We see so many companies now popping up along those lines. So we're telling that if you are smart, you should be able to leverage what is best in a given context. And the logistic infrastructure should make this easy to happen. So obviously it includes also the usage of multimodal transport, which we saw on the left side. But very simply, but very important, is to think of multi-size vehicles and carriers. Okay, so thinking that a single truck size will do the job doesn't really work. Okay, sometimes we need a 40-foot, 53-foot semi-trailer with tractor, but sometimes a delivery van is enough, and sometimes it's just a pickup, and sometimes I can do it with a tricycle pulling a small trailer, and sometimes I can do it on a backpack. So we have to think that all those options, okay, are possible, and if we can have access rapidly to them and smoothly with not too much extra charges depending on the options, that can have tremendous impact. So it's this combination that we're dealing with. And this helps coping with, on one side, the time and price sensitivity of customers. Some want it very fast, okay, and some do not worry too much about the time, but are very conscious about price. And you've got plenty of people in between. We need to be able to deal with those customers so as to make them as satisfied as possible. We don't do it profitably though. And also we have to deal with demand variability and uncertainty, because there's a lot of things happening in the field, and we've seen it through COVID, obviously, okay, with huge transformation happening within a few days and weeks, okay, that closed down blocks of the industry, while other blocks were completely overloaded. So if we can play around and switch easily, that helps tremendously. So all of this into an economic, environmental, and societal sustainability perspective out of it. Now, let me go to another facet that we have found, okay, through working with several players in the, okay. It essentially, the logistic infrastructure leverage our knowledge of Shenzhen and deep knowledge of Shenzhen in work that we've done in the past years, to show you an example. Okay, so I've got like here the Shenzhen, and you saw there are white areas, but this is geography, so it shows where there are logistics activity, and essentially there's been work done to optimize the structuring of space at the urban area level. In this case, we've tested several ones. In this example here, we have 6 urban areas, okay? And within these areas, you see more divided type of spaces, and this relates to 103 local cells. And those, okay, are clusters of roughly 3,500 unit zones, essentially. So three levels here. So I'm showing here the overall, and then I'm focusing on urban area 4. Okay, so we see in the central part and bottom, which is very dense. Okay, there's a lot of towers there and a lot of density, and we see here the 37 with changes of color, the local cells, and we see the nearly 1,200 unit zones that are comprising that. In the concept here, unit zone is where a courier would essentially spend most of its time doing pickup and deliveries, while when I'm going at local cell, that would be now doing more like within this local cell, united all the operations. So adjacent to this part of the logistic infrastructure is the network, okay, of hubs that I'm putting there, and I'm going to connect them. So we're talking overall about the logistics web, which is a network of network. And those networks are essentially defined in multi-planes in the proposal here, and they are mostly mesh network with not like going direct from long distances, but interconnecting through the way. I'm going to make this very clear. This is in line with the unit zone, cell, area, region, block, world type of space aggregation. So we have defined here a number of types of hubs. Okay, so if I start at the bottom, okay, I have the pickup and delivery points. They're not really hubs, but this is like a smart locker. This is the receiving area of company Y, and so on and so forth. Then we have the first level of hubs, which are the access hubs. They're normally small. They can be looking a bit like a smart locker, but defined for the logistics service providers, or a small room in a building well designed for this. Then we get to local hubs, which are going to be like inter-cell level. And then we have gateway hubs, regional hubs, and global hubs. And so a hierarchy of these. So from point A to point B, and they are very near to each other, okay, then essentially I can just go directly at the access hub network and go direct, okay? But if it's a bit farther, I may have to climb to the local hub network, okay? Do a bit on the local hub network faster. It's like going from a small street to a boulevard and then highway and so on and so forth, kind of logic like this, and then go back down, okay, to the destination. And if it's 2 different parts of a bigger mega city, I would climb up to the gateway hub level network, move along the gateway hub network, and then go back down to local hub, access hub, and to the final destination. So such networks, okay, such spacing in network has to be taught, okay, from a dynamic perspective, okay? So they're multi-party. This is not something to be imposed drastically. So there are many companies that have different hubs, but now the notion is, can they make them available partly through the overall infrastructure? It can be a specific facility that is open. They can be having a network that's mostly private, and then interconnection at given points with other networks. There are going to be a variety of them, but we have to account for competition, cooperation, competition, but we want to minimize duplication and waste through the process and maximize efficiency, fairness, resilience, sustainability through this. And overall, these networks, even though they may look complex, they should be very simple to leverage, operate, and evolve. Now, I'm going to climb, and show this for a place like Shenzhen in China. So first, I'm showing we had 6 urban areas, and we've developed here 11 gateway hubs that are interconnecting them, and also connected to 2 regional hubs. One is a bit upper north, okay, one is on the western boundary of Shenzhen. So this proposal, and you see the hubs and the overall type of logic that is at stake. This is not meant to be comprehensive, just illustrative. And by the way, okay, none of these networks are in space clustering are meant to be prescriptive, but rather illustrative of the talk that I'm doing here. So here what we go is one level deeper. Now we have the local hubs. What do they mean? So I have local hubs depicted in green here in each of the areas. I've got 150 local hub in this example. And then I'm adding the access hubs. But here, as we'll talk later on, I'm not really talking about the access hubs themselves, but the access hub sites. Okay, so I've got over 4,000 access hub sites that have been identified where I can put an access hub. I will come back to this later on. So we're talking Megacity. Okay, so Shenzhen has 15 million people. Obviously, if I'm in a little township, okay, where I was born, you would not have much simplified than this. But if we can do it for large cities, okay, then we can definitely do it for all kinds of cities around the world. So showing here, there seems to be a lot of density. So what I've had is a last figure where I'm showing one urban area and now focusing, okay, and showing you the kinds of hubs that we see. With the in small blue are the access hub sites, green are the local hubs, and we see the gateway hubs there. So I'm not showing all the links, obviously, but you see that they're position so as to facilitate transfer. So the kind of movement I mentioned earlier will be easy to happen. Now, this is within one city. Now, if I look at all of China now to get the idea of what this means when I'm taking a major country like China, and it's not complete again, but it covers a lot of the economic activity of China. So what you see here is in blue, star blue, you'll have the regional hubs that are proposed. On the order of 60, and I think in this example. And then you see the gateway hubs associated with the over 300 cities that are in China, with some of the bigger cities having more than one gateway hub into it. And the idea here is that we can go from any hub to any hub, even the regional level, okay, with less than half a day, meaning that we can get all the drivers back home every day in there. So this is fine, but it just shows the trucks. Okay, in practice, I have to link this to the rail, I have to link this to the maritime side, and also to the air one, especially when I'm dealing things that are more express, okay, requiring speed. So here we're adding and interconnecting the land-based network and the air network to be able to calibrate how we can offer faster services from source to destination without having to have direct links from every city airport to every others full of cargo, which may be possible in some cases, but overall large scale, there's a lot of nice features about consolidating this. So this is the spirit of this a large scale type of network infrastructure we're talking about. shifted location depending on demand. So depending if demand is higher and I need more space, okay, in my access hub, I don't have to reinvent or recreate another hub. I'm just shifting some adaptable modular possibility. Scalability is about all the hubs. Some are going up, down. So the same logic of being able to contract and expand the various levels of hubs as demand expands or retract without having to completely destroy everything or start new things. Doing this very fluidly through time, so that this overall logistics web adapts through time and it becomes very resilient to what's happening there. So you see them moving, okay, again. And now what I want to emphasize is the notion of mobility. Especially when I get to the smaller types of hubs, like the access hubs, then why do we have to freeze them at a given location? It makes much more sense to allow some of them to be fixed, but some of them to be modular. So we have the basis and can retract and add or remove modules, but also in some cases to have access hubs that are strictly mobile. Okay, here's an example used by UPS, where essentially it's a trailer in location. You see the way they've designed it. Okay, and they were doing this in Munich. So this can be expanded large scale, okay, in the thousands of hubs that I've been talking about earlier. Not all of them should be mobile, but there's room for them, and our studies showed that there's significant potential in doing such things. So, but overall, understanding that it's like when we used to have phones that were attached land mile, and now we're all on mobile phones. So it's still the same kind of technology concepts, but now we're not as anchored as we were in the past. Now, I've put emphasis on the logistics facets, the objective, etc. Now I want to, with a few slides, emphasize the fact that we need technology, okay, to information communication technology to make this happen. So essentially, we'll need a cloud-based digital supply chain and logistics interconnectivity platforms into this. So here I'm showing several facets of this, okay, marketplace where we can match, orchestrate, optimize supply and demand for movement of goods, for availability of goods, so and for fast, seamless, fair contracts into it. Now, we have to track what's happening, make sure that we've got the visibility, the traceability about what's happening in this infrastructure. So I've put it under Internet of Things, but all those sensors, actuator, connectors, the connected devices that inform us, okay, about the current state of the network. There's so much more we can do than we could have done 10 years ago. So this is huge potential here, quite achievable and already achieved in many contexts. I've added blockchain as this notion of trustable with all the hackers in this world and all the bad players, let's put it this way, okay, that are trying to threaten the operation of logistics network. It's important that whatever is written digitally, that we have confidence that it really happened. So for visibility, traceability, but also relative to the ability of doing smart contracts into it. And simple links is put there as a very simple way to show that when I put some a t-shirt in a container in a truck, etc. So there is a way by clicking every time, because we know that one has been put on the other, that I can track the truck, and I know that the container is in the truck, the object is in the container. So it makes easy to track for those that are knowledgeable and are responsible and have access to that information to track the various objects, while keeping the rest private as should be. There's also significant decisions, okay? So we should not think that all this is a piece of cake, easy to decide on everything. No, there are several decisions here. In fact, the physical internet and this hyperconnected infrastructure allowed to decouple decisions that were all tangled together. So we would talk about vehicle routing in the past, like a big deal. That's still there, okay? But now we also have to deal with the freight routing, the parcel routing, thing. We have to deal about the containerized consolidation, what I've put in a single container, why did I put there, so that they would travel together long and not having to deal with that object for quite a while, and then when the pertinent, change it. So all these notion of consolidation within containers, between containers composed together or put in given rack, in making sure that all this containerization is done smartly, dynamically. Network design, which used to be thought mostly as something that we do very strategically, is becoming much more tactical and even operational tool when we're having mobile type of ops. So all this becomes part in there. And also the kind of service we're going to do. So we've passed a time where things were very rigid type of offers with cutoff times and specific pricings and times, etc. And now switching to something that's going to be much more listening to what the client wants in terms of speed, what he wants or she wants in terms of precision, time windows, and the kind of price they're willing. And based on this, putting together offers that are going to match their need as best as possible. So all these decisions are interlaced, but they have to be taken by different agents and across the entire logistics web. So this has to be done on a very efficient, simple, easy to implement ways, okay, that rely mostly on protocols, okay, that are going to be observed by and respected by the multiple parties. It requires predictions. We used to be able to do very little of this in logistics, except on more like tactical and strategic. Now it becomes possible with new kind of technologies, algorithms, and new theory to be able to do it much more rapidly, so that we can react live about predictions, both from on movements of goods, where they're going to be, etc., but also on forthcoming demand at a very precise space-time level. And clearly, the various decisions that within those protocols, there still remain to be done. So we have to think this. So it's going to be enabled by analytics, AI, data science, digital twins, heuristics, machine learning, optimization, simulation. So this is telling essentially that we need to put all the smartness into it, and it's going to be a game where as you get smarter, okay, and you can perform very, very much. Now, as we are in the midst of COVID, at Georgia Tech, we, and like many people around the world, okay, we've been thinking about what are these aspects. There are several of them, the impacts on logistics supply chain. But one that we thought should be added to this notion of infrastructure here is the notion of a vector-free logistic infrastructure. So the idea is that logistics receives, unpacks, sorts, moves, packs, ships, transport, delivers goods, okay? At every step, there are people, equipment, products that can become vectors propagating pandemic viral diseases. So we want to make sure we avoid this. So vector-free logistics is about having the overall multi-party logistics system in a large territory, ultimately all around the world, that is designed, engineered, implemented, operated, managed, not to be an infection vector, protecting the workers, the customers, and the population from diseases, while not being encumbered into inefficiency, rigidity, and unsustainability. This is a very big endeavor. And will we reach full, perfect vector-free logistics? If it ever happens, it's going to be a long time. But every step we go in that direction is a big plus. Okay, it includes a bunch of ideas. Okay, that in ways that can be put together smartly: product and equipment decontamination, worker protection, the modular containerization, making sure we don't touch with the specific object and what's inside has been decontaminated, so just the outside need to be touched. Using robotization and automation that are not by themselves affected by it, even though they could be carrying it. Autonomous transport, the same thing. Doing as much as possible touchless operation and relying much more on digitalization so that we don't have to exchange paperwork, we don't have to go on site to do things, so the potential contact is lower. In the overall principles, protocols, and interface that we're using, the physical internet, having changes at hubs and going from hubs to hubs and all this, okay, can make it very clean, because every time we are in control of what's happening there, and we can make sure that this can be measured, protected, and so on and so on. And clearly it needs customer collaboration to make this happen on both sides, on the inbound, outbound side as well. So with this one, this concludes my this. I'd say thank you very much for having listening to this, and Cheche to our Chinese people for attending, and also for organizing such a conference in such a tough, troubled time. We will remember this for decades, and remember the strong work and dedication committed by the organization to make it happen, even though we had severe issues to face. Questions, comments, feedback, suggestions are most welcome. It's been a pleasure. I'm Benoit Montreuil, and thank you very much for listening to me. Thank you. Bye.